was a long weekend, right?
Yes, it was.
I was a little busy with my many
Yes.
things came to like suddenly everything, right? So okay, so control why it's not getting, yeah. Hey, hi Renee. So let me recap what we have done. So we have covered the OSPF DR and media concept. So we have basically seen that the role of the DR media, why this thing is not happening in the EIGRP protocol. We have also seen that what's the major difference between the EIGRP and OSPF protocol, right? So if you guys remember that, in this diagram, right, we have have a area zero. So OSPF works on the area concept, and area zero is a backbone area. It's a 32-bit area range we have. So apart from the area zero, all the areas are known as a normal area. For example, area one, area two, area 10, area 20, area 30. All these areas are called as a normal area. In the one broadcast domain, what happened to manage the one broadcast domain, we have a DR, and for the DR, we have a backup DR. So if the DR goes down, so backup DR will take a role of the DR, and another router will become the DRO. So election criteria of the DR and VDR is what? If you guys remember that the higher priority will take the precedence. That's the election criteria of the DR and VDR. Right? So the first is going with the higher priority. And the default is one, of course, right? And you can configure up to 255. It's an 8-bit number, you can call it. Someone is on. And if the priority get tied, then what happens? It will go with the higher router ID. So again, router ID is a 32-bit number, right? So if the priority get tied, then it will go with the higher router. That's the election criteria of the DR BDR. Remember one few points, if you guys remember, like in every broadcast domain, right? Let me use my keyword. Why it's not working on keyword? Hold on. It's not guys. In every broadcast domain, why it's not working? Yeah. In every broadcast domain, we have a one DR and DR, right? We have a one DR and BDR. So if you want that interface to not participate in the DR and BDR, if you want that interface should not participate into DR and BDR, then simply what you can do that, configure the priority zero. Priority zero is called as a special priority. So if you're going to configure the priority zero on the interface, so simple command, you just need to go on the interface, I the IP OSPF, priority will be zero. So that interface will never become a DRBDR, right? That always go with the DRO. And either what you can do that, you can change the network type, right? From broadcast to point to point. So in the point to point, if you guys remember that we have discussed this thing. Normally in the what we call, we have a 4 types of network type in the OSPF protocol, right? So we have a point to point, we have point to multi-point, right? If I need to talk the network type, we have a, come on, we have a broadcast, which is the by default on the Ethernet technology. On an Ethernet what? Ethernet means fast Ethernet, gig Ethernet, 10 gig, 100 gig. Nowadays, you always see the Ethernet only. Another type of the network type, we have a point to point. So point to point, you will see on the default behavior on the serial link. Nowadays, you will not see the serial link. Yeah, but it doesn't mean that it's not available in the market. Recently, I have encountered the serial in one of the production network, right? Another type of network, we have a point to multi-point, if you guys remember that, right? So in the point to multi-point, we don't have a DR and media concept. And the fourth one is we have a non-broadcast. Come on. That's sometimes it's called the NVMe network. So normally in the, if I talk about in the DR, PDR is present in the broadcast. So we have a DR and BDR over here, right? So the election of the DR, BDR will be in the broadcast network and in the NVMe network. So we don't have a DR and BDR concept in the point-to-point link and point-to-multipoint link. So basically, if I talk in not simple language, right? So these two network type that you can see that right now, these two one, the point-to-multipoint and the non-broadcast. This is normally you will not see in a normal behavior. See, this is obviously not seen because it was a concept of the frame delay, right? So very older technology, no need to it. This point-to-multipoint, you will see that when you have a DMP scenario, right? When you have a DMP scenario, then you can see the point-to-multipoint. But if I talk about the whatever the newer technology is coming in the market right now, SD-WAN, if you see that, in a SD-WAN technology perspective, if I talk about, so we only have a broadcast and point-to-point. That's all. Only two types of network we have, right? So even in the, like if you go for the interview, they always ask you the broadcast and the point-to-point. That's all. So they will give you the scenario. Hey, can you help me out? So we have a router number one and we have a serial link. Tell me who will be the DR and BDR in this. Of course, there will be no DR BDR because there is a serial link out there. So, okay, that's fine. Then they will ask you, okay, this is the interface we have, this is the 0/0, F0/0, F0/0. Now tell me who will be the DR BDR. Of course, those have a higher priority. If the priority get tied, then it will go with the higher route ID. Okay, that's fine. Then he will say you, okay, I configure the priority 0 over there and priority 0. Who will be the DR BDR? So priority 0 is a special priority. There will be no DR BDR for the priority 0. Then he will say, okay, that's fine. The priorities are, I have configured the priority 255 and I configured the priority 255 over there, but I changed the network type from broadcast to the point-to-point. So if you remember that we have seen this configuration. So you just need to go on the interface as the, IP OSPF, right? And network type is what? Network point-to-point. So what happens if I'm going to configure the point-to-point? Obviously, it doesn't matter if you configure, if you have a priority 255 and 255, but if you change the network type as a point-to-point, on the point-to-point network, you don't have a DRV. So even the Ethernet technology that you can see that the fast 0/0 can be converted into the network type point-to-point over there. So these are the very important questions that may encounter in your interview guys. So let me put this way. Okay, so if you change the priority, we have an interface 0/0 or change the on the point, you can change the network type from broadcast to point-to-point. And this is the network type we have. Anybody has a question, guys, in this topic, you can feel free to ask me. No? Okay, let's move forward. So, great. So I'll have a one question for you. So the requirement I'll tell you, then you give me the answer. This is the route because this is the very important interview questions. I have many times encountered this question, many times. So the requirement is what? This is of course we have a 12.0 network. This is the 13.0 network we have. This is the 14.0 network we have. This is the what we call 15.0 network we have. What I want, we have a 0/0, we have a 0/1, we have a 0/2, we have a 0/3. What I want, the R1 should be the DR, right? R1 should be the DR for all the broadcast domain. What you will do that? R1 should be the DR for the all broadcast domain. Yep.
You're the highest priority?
Priority, how much? Priority
Highest
255 on all the interface. Not highest, it always go with the 255. Because take example, if you configure the higher, what higher you will do that? Maybe the 2, 3, 4, 5, 6, 7, 8, 9, 10, maybe the 100. So if you're going to configure the 100 on this guy, and maybe on another interface, they configure the 101, he will become the DRB, he will become the DR now, right? After the OSPF will restart. So go with the 255. Wait time we have, that's by default 40 seconds. you cannot change the wait time. It's very, very important. You cannot change the wait time. If you change the dead interval of the OSPF protocol, the wait will be automatically changed. For example, if you say the dead interval is a 120 second, the wait will become the 120 second. So the wait timer is the timer for the DRVDM. All good. So that's we have done. Also, we have covered the basic configuration part, if you remember that. So we did the basic configuration, the sense of what we have router number 1 and we have router number 2, right? And so router 1 and router 2, we have a link between, not links, of course, sorry, IP address between router 1 and router 2. So we have a 0/0 and we have a 0/0 as well over here. And the link we have over here is called as a 12.2, 12.1, this interface. And I call this guy channel 1 or 12.0/24. This interface is a 12.2 we have, right? So if you remember that, I have configured the basic OSPF parameter over there, router OSPF number 1. So this is called as a process ID. That's 1. It's a 16-bit of number. You can go with the any number. And it's a locally significant. So if you're going to configure the router 1 as a process ID 1 and router as a process ID 2, they will still form the navigation. But in the case of EIGRP, if you configure the router EIGRP number 1 over there, and if you configure the router EIGRP number 2 over there, it won't work. They will not form the navigation. So network we have a 10 or 1 or 12 or 0, and then we have a wildcard mask and area 0. That's all. Same thing on the router number 2. If you want to define the router ID manually, you can also do the router ID manually 2.2.2.2, and network will be 10 or 1 or 12 or 0, and that's all. The area 0. You can define in the dotted decimal format as well. So area you can define in the decimal format and dotted decimal format. Area, let me write the process ID concept. Process ID is a 16-bit of number. It means that you have from 1 to 65535 on a Cisco iOS router, right? And it's a locally significant number. The meaning of locally significant, you will encounter this terminology, locally significant, globally significant, many times when you go with the higher level of the technology, like a CCI route switch. So not route switch, enterprise. So locally right? Locally significant is what? So router 1 has a process ID 1 and router 2 has a process ID 2, right? It will still form the navigation because in the hello packet, we are not going to exchange the process ID number. Like an AD value, administrative distance, right? It's a locally significant. We are not extending the AD value in a update packet. But AS number that we did in the EIGRP, that's not a locally significant because we are extending the AS number in the EIGRP hello packet, right? And for each process ID, we have a separate database table, which is known as a LSDB table, link state database table, right? For each process ID, we have a separate algorithm, which is known as a SPF algorithm. So understand the concept, guys. So, you may say that, okay, it's a locally significant. I can configure the different process ID. Of course, you can configure it, but what problem will be happening. Take example, this is router 3 we have. This is the link between the router 1 and router 3. So for this particular link, I have configured the process ID 1. For this particular link, I have configured the process ID 2 over there. What happened in that case? On the router number 1, you will have a 2 database table. One database table for the process ID 2, another database table for the process ID 1. And for each database table, that's a LSDB table. For each database table, what happened? You have a separate SPF algorithm. So CPU comes in the picture, memory comes in the picture, that will degrade your router performance. So it's very, very important, right? Your process ID should be same in the entire network. Now you may have a question, hey, no, if the process ID is a locally significant, and if they still form the neighborship, then where the use case of this thing? Definitely there is a use case. The use case is what? Let me explain you. I can't give you the much detail, but understand the concept. So normally this is the service provider we have. Service provider have router 1 and router 2 we have and router 3 we have, right? So service provider is running with the OSPF process ID 1 right now. Okay. and this is a C, customer edge, and this is the another customer edge we have, right? So the customer is running with a different process ID. Maybe they are running with the OSPF number 2 at Delhi location, and this guy is running with the OSPF number 3 at Bangalore location. But which process ID they are running? They are running with the process ID 1, they are running with the process ID 1. So still they can form the neighborship, still they can form the neighborship. So in that way, you will see the different process ID, because ISP is not gonna depend on you. Because for the ISP, we have a different customer. For another customer, what happened? Out of 5 we have, this is another customer, they are running with the OSPF process ID 100 maybe, and they are running with the OSPF 1. So service part is running with a different process ID, customer is running with a different process ID. So you will see this kind of scenario when you go in the service provider level, then you will see that. But yeah, in the single company, that is always a recommendation to have a same process ID. Otherwise, what happened? Your router will consume the lots of memory and CPU over there, right? So I hope this thing is clear to all of you guys, the meaning of process ID concept, right? And what I told you that, if you remember, so once you configure the OSPF protocol on a router number 1 and router number 2, both the router is going to exchange the hello packet, right? And if the hello packet will be match, the neighborship criteria will be matched, then they will form the neighborship. So whatever the neighborship criteria we have, can anyone tell me? Can anyone tell me whatever the neighborship criteria we have?
Subnet mask area should be same, sir.
Perfect.
And
So network
All time.
and
Hello timers.
subnet mask will be same.
hello dead interval should be same.
Perfect. Hello and dead interval should be same.
Network should be same.
Say I mentioned the network over there.
Oh, okay. And stop area should be same, sir.
Area should be same.
Oh.
Anything else? Router ID must be different, right?
Yes,
Anything
sir.
else? Now the stuff and NSA flag must be seen. We'll see that.
Yes, sir. MTU should be same.
MTU is not comes in the neighborship criteria, that comes in the adjacency criteria. Network type must be seen.
Okay,
Just
okay,
for
sir.
now, when you come to the CCI level, you will see the difference in the network type. You know, I'm not gonna say that the network type should be same in the CCI level. It's little different, right? So basically, if you see, these are the neighborship criteria that you have. Make sure that authentication also should be same if applied. Optional. And passive interface should not be here. Again, it's optional. So if you configure it, then you will see that, otherwise no. So these are the neighborship criteria we have in OSPF protocol. Make sure that it has to be same. And all these things are going to exchange in the OSPF hello packet. Everything will be exchanged in the OSPF hello packet. Right? So if all the parameter is going to match, then what happened? If the router 1 is going to send the hello packet, so router 2 also going to send the hello packet. All these parameters will match, then they will form the neighborship. If the parameter is not matching, if anything is not matching, right, they won't form the neighborship. Right? So once this guy will be done, then next packet comes in the picture. Let me show you this thing this way. Let me go with the different lab. Or maybe I can show you. Let me go with a different lab. So I'll go with the small lab, new lab. I have a DFT. All good, right? So this is the router 1 and router 2 we have. Let me change the color. I don't like this older base. Put some 3D view. All done. So we have routers over there. So what happened? I don't know what's not reaching, leave it. So we have router 1 and router 2. And let me put the IP addresses over there. So I'll configure this guy the 12.1. This is subnet we have 10.1 to 12.0/24. This is the 12.2 we have, right? And of course, I will consider there is a few loopbacks we have. I'll consider VLAN number 10, and that's a. I'll configure this guy as a 1.0.0.0. VLAN number 20 we have 0.0.0.0. Same thing. I'll consider the VLANs over there. It's a VLAN number 10. We have a 3.0.0.0, and VLAN number 20 we have a 40.0. So we have a two VLANs behind the router 1 and router 2. So you can consider these are the LAN network we have. These are the LAN network we have. So let me configure this, guys. A simple configuration we have. If you see interface, you just need to go in the config table router number 1. Interface gig 0 slash interface fast 0/0 IP address with 10.1.12.1/24. No shut interface loopback number 1.1.1 and /8 interface loopback number 2 2.2.2. So what I told you that if you remember that, will you tell me one thing? How many host bit we have in this IP? In this subnet, how many host bit we have? 24 bit is a host. It means that we can range a bunch of IP address we have in this particular host. We have a bunch of IP address in this part. Guys, please try to understand this behavior. Very, very important. Okay, if your comparison with the EIGRP protocol. In this network, we have a 24 bit is a host bit. It means that we can give the bunch of IP addresses, right? We can give the bunch of IP addresses on this particular network. But try to understand, I have allocated the interface loopback number 1. Loopback is a logical interface, and each loopback is treated like a separate broadcast domain. So if I have already assigned the /8 over there, can I assign the same IP address to the another loopback number 2? No, I cannot do that. In the EIGRP protocol, what happened if I'm going to configure the interface loopback number 1, and if I'm going to advertise in the EIGRP protocol, what EIGRP will do that? It will simply advertise the 1.0.0.0/8 network. EIGRP is not a smart protocol. What OSPF is doing that? In the OSPF protocol, if I'm going to advertise this route, what happened? OSPF said, hey, you know one thing, I'm better than you. I know this is the loopback route. This is a loopback interface, okay? And on this loopback interface, you have configured the 1.1.1.1. And loopback is a single interface. It's last interface, single interface we have. Apart from this IP, you cannot configure any other IP address on this guy. So what I will convert this guy, anything if you're converting the /8 configuration, if you do the /8 configuration, they will convert into the /32 as a host route. Host route is called as a single route that is only for the particular person. Right. So can you see that in the EIGRP protocol, if I'm going to configure this guy, I will take the little bit more memory and more CPU. But in the case of OSPF, I'm going to take the less CPU and less memory. I can see the lots of IP addresses. Now on the interface loopback number 2, I can configure like this way now. On an interface loopback number 3, I can configure like this way now, which is not possible in the case of what? EIGRP. In a EIGRP, if you want to configure like this way, then you need to manually configure the /32. That's a beauty part of the OSPF protocol we have. So now on the router number 1, same thing on the router number 2, we need to do that. On the router number 2, we have to configure the same configuration. I have a 12.2. We have a 3.3.3.3. And we have a 4.4.4.4. Right? And let's configure the OSPF now. Router OSPF number 1. Network 10.1.12.0. I'm gonna configure as an area 0 right now. See, let me do on the first IP configuration, then we'll do the OSPF. So OSPF is a network layer protocol. It's a layer 3 protocol that works on the protocol number 89. EIGRP works on the protocol 88. OSPF has a two multicast address. One is for the 224.0.0.5. Another is a 224.0.0.6. So .5 is for the DR and media. .6 is for the all OSPF data. Now let's see, do we have any configuration? No, let's configure it. Okay. How the router number 2 now? Come on. Now what I can do that I'm just going to capture this particular link. I've already explained you the hello packet. If you guys remember that, I'm just recapping the one more time. Okay, so I'm just going to do the advertising the only the physical interface right now, not the loopback interface. So let me put this command on the router 1 and router 2 as well. Okay, let's leave it. So of course, router ID will go with the 2.2.2. Okay, 1 minute. Let me change the router ID will be so the 11.11.11.11. Okay, so I think so they have elected the router ID, so I need to restart the process. Oh, come on. Router ID will be 20. So they already elected the router ID. So if you want to put the router ID this guy, then you need to restart the process. So previously router ID was 2.2.2 because of the highest loop back. Now it's what 11.11. Same thing on the other one, if you see. Okay, wait for some time more. OSPF is a little slow protocol, man. So 40 seconds, the DRB state is going on right now. So all done, we form the navigation. So if you see the hello packet of the both the protocol right now, what I can do that. If you see the hello packet from the, if you see this is the R1 is sending the packet 10.1.12.1. That's the router number 1. This is the MAC address of C201. If you see that, the C201 MAC address is the router 1 MAC address. If you just go and put this command on the router 1, do show interface 0/0 include BIA. You can have a look C2013770. That's the MAC address of the router 1. Destination is the 01005 is 00005. That's multicast MAC address for the all those protocol. The TTL is 1 and the protocol number is 89. And now we have a OSPF protocol. OSPF header, we have a version 2 by default hello packet. This will be changed according to the packet types. The length of this packet is a 40 bytes. So the message tab will be changed. So either it could be the either it will be go with the hello packet used to form the navigation, right? And maintain the navigation by sending the periodic hello packet at every 10 seconds. Then the next packet we have over there. So this will be changed according to this type value. You can see that this will be changed depending on the packet. So next packet we have a DVD packet, database descriptor packet we can call it. Right. So this packet contains the MTU field and this packet is used So selection of master and slave. I'll come to this point. What is the master and slave? Don't worry about that. The next packet we have what's called as a link state update packet. This packet contains the LSA's information. Simple language you can call as a route information. Like LSA is eventually a route, we can call it. So then next packet we have a link state request packet, LSR. Link state request packet. This packet is used to request some information to the neighbor router. And then last we have a link state acknowledgement packet. ACK packet. It's a receipt of LSU packet. Like a acknowledgement packet we have in the EAGRP. So whenever the update or whenever they need a reliable packet, router 1 is going to send to the router number 2. So EAGRP router number 2 will send the acknowledgement packet. Same like that one. So if you see, right? DVD packet is for the master and slave. LSU packet contains the LSA information, you can call it route information. LSR is just for the request and link state acknowledged for the receipt of the LSU packet. That's all. So if you see, this is the hello packet we have. This is the header we have, hello packet, OSPF packet length of 44 bytes. Source is the OSPF router 2.2, router number 2 is sending this, router number 1 is sending this packet because router 1 has a router ID is the 2.2.2.2. And area ID is a 0.0, it's the backbone area. And then we have a 1 minute, this is the older packet, 1 minute. Because I have changed the router ID. It should be the 20 dot something, 20.20.20. Yeah. So there is the 11.11.11. This guy should be 20.20.20. So router ID of this guy will be 11.11.11.11. I have changed that one. If you remember, this guy has, I changed to the 20.20.20. 22.22.22. So area 0 is the backbone area, and checksum that's maintain the integrity of the OSPF header. And then we have authentication type, it's a null. So null will be 0. If you have a text authentication, then it will be 1. And if you have an MD5, it will be 2. We'll see that in the authentication part. And then we have a OSPF hello packet. And these are the information: network mask, interval, hello time, dead interval, router priority, that the interface priority that's for use for the DRBDR. Options field, if you see, we have a this is called as an NSSA flag, right? And this is called as a stuff flag. We'll discuss this thing, don't worry about that. And then we don't have a DRBDR right now, that's why it's a 0.0. And my neighbor is a 44.22.20.22 over there. So that's my hello packet. Then after what happened, once the hello will be done, and once the neighborship criteria will be matched, right? Once the neighborship criteria will match, then what happened? The router will exchange the DVD packet. The use of DVD packet was to elect the master and slave. Now, why this two terminology comes in the picture, master and slave? So take example, understand this concept, this example right now. So there's a two person, right? And so take example, this is the, so this is the Anil, and this is the Boozer, right? So these two guys are a very good friend, like a childhood friend. And what happened after the 20 years, right? After the 20 years, they met in Bangalore airport. Understand the concept? So they met in the Bangalore airport after the 20 years, and suddenly Anil saw the Boozer and Boozer saw the Anil. Okay, so they are the very good friend, right? So of course, these guys has a lots of information to share with the Boozer, and Boozer has a lots of information to share with the Anil. So they are fighting to each other right now. Hey, one thing, I have a lots of information that I want to share with you, and Anil is saying that, hey, I have a lots of information that I want to share with you. So they are both fighting right now to just exchanging the information. So what we did over there, then Anil said, okay, you are elder than me. You can share the information first, then I will share the information, right? Same thing is happening with the OSPF protocol. In OSPF protocol, what happened? Both the router has formed the neighborship. After forming the neighborship, what happened? Now we are ready to exchange the database, right? Now we are ready to exchange the LSA information. So both are fighting each other. Hey, no, I want to first share the information. He said, I want to first share the information. Then what we did, we said that, okay, we'll make an election of the master and slave. So the router who has a higher route ID, the router who has a higher route ID will become the master, and the router who has a lower route ID will become the slave. So router 2 will become the master because he has a route ID is a 20.22.22 to 22, and this guy will become the slave. So router 2 is gonna share the summary information about the LSA, right? Summary information means what? Understand the concept. The meaning of summary means what? So take exam, same thing. So both are the childhood friend, right? So what happened? So they were in the classroom, and in this classroom, they had a one beautiful girl. So this girl name is maybe Nidhi, right? So what happened? So Anil and Buzar, they are and Nidhi, they all are the friends in the in the childhood, right? So Anil has a number of 1, 2, 3, and Buzar has a number of 4, 5. So this is the phone number we have. Nidhi has a 7, 8, 9. If you understand this, example, you will understand the packets of the OSPF protocol. So basically what happened, understand. So you have understood the hello packet till now, right? Hello packet is just to form the neighborship. That's all. Then what happened? We understood the concept of the master and slave. The use of master and slave is what? Who will exchange the information first? Who will say the database first? So master will say the database part, and the election of the master and slave is what? Highest router ID. And the lower router ID will become the slave over there. Now, this master slave information will be done in the DBD packet. Right? This master slave information done in the DBD packet. Now understand the concept. What happened? So Anil, right? Anil has a number, Boozer has a number of Nidhi as well. So he said, hey, I have a number of Nidhi as well, 7, 8, 9. So Anil is asking to the, so not Anil. So Boozer is telling to the Anil, hey, Anil, I have a number of Nidhi. Understand the concept. He is just saying that I have a number of Nidhi. I have a number of Nidhi. He's just saying that I have a number of Nidhi. He's not saying the number of Nidhi. He's just saying that I have a number of Nidhi. Okay. That's a DBD packet. In the DBD packet, what happened? I'm just sending the summary information. Summary information means what? I'm just telling that I have a this amount of route. I'm not sharing the route. Understand the concept. I am not sharing the route. I'm just saying that I have a this amount of route. R2 is just saying that, hey, one thing, I have a 2 route. But understand, actually, it will be the LSA. Why I'm saying the routes of the right now, so that you can understand. But eventually this will be LSA. So he's saying, hey, I have a few LSA in my database table, but I'm not sharing the LSA information. Same thing. I'm just telling that I have a number of Nidhi, but I'm not sharing it. Router 1 also share the summary information. Hey, I have a 2 LSA as well, and 2 routes as well, we can call it. Simple language. Then what happened? Now Anil will request to this guy by sending the which packet? LSR packet. So in the DVD packet, I just say the summary information. By requesting it, hey, can you please give me the number of Nidhi? Can you please give me the number of, that's the meaning of request packet. Same thing, when the router number 2 has shared this information to the router number 1, and router number 1 shared this information to the router number 2, then what happened? Now the router 1 will say the LSR packet on the in the response of this packet, and then router 2 also send the LSR packet in the response of what? This packet. Requesting it. You have shared this information. Now I'm requesting, give me the information. So when I'm send the LSR packet, now what happened? Now Boozer will give the LSU packet, link state update. And in this link state update packet, same like a EIGRP update packet. In this link state update packet, what happened? You have a number of Nidhi, 7, 9. Same thing. Once we have exchanged the LSR packet, now the router 1 is going to share the LSU packet. In this LSU packet, I'll put this information. And same thing, router 2 also send the LSU packet, and this LSU packet, what happened, they will put this information. So finally, we are going to exchange the information in the LSU packet. Right. And now once the Anil will receive the LSU packet, where we have a number of 79, he will install the number 789 in the database table. And now he will give the acknowledgement. Hey, thank you so much. Right. Let me now talk to the Nidhi. Same thing. He will send the LSU. Now he will give the acknowledgement. He will give the acknowledgement. So this is how your OSPF packets are working. So DVD packet is just gonna give you the basic info. I just have a number of Nidhi. I just have a 2 dot. Okay, you have a 2 dot. I'm requesting it. Give it to me. That's a LSR comes in the picture. Link state request comes in the picture. Right. Once the request has done, now I'm requesting, I need an information. Then what happened? You need to send the information. That's LSU comes in the picture. And once the link state update will be exchanged, OSPF is a reliable protocol. We need to send the acknowledgement. Right. So if you see the DVD packet, in the DVD packet, I'm gonna put the MTU information. That's a very important one. And if you see the flags over there, that's a use for the master and slave flag on this one. This is the master and slave MS bit. So in this DVD packet, I'm just gonna share the summary information that I have a LSA, right? Not this one. See, Rado one is saying that I have a LSA, but I'm not sending the detailed information. I'm just sending that I have a LSA type 1. I'll explain you what is the type 1 LSA. Don't worry about that. I'm just saying that I have a type 1 LSA. That's all. That's Rado one is saying that because Rado ID of this guy is a 11.11.11. Right? So R1 is just saying that, hey, I have these information that I want to share with you. Router 1 is saying router number 2. Then what router number 2 will do that? Okay, perfect. You send me the DVD packet. I'm requesting it now. LS request packet. Can you see that? The same information I have sent in the DVD packet. Understand the concept? See, the same information I have sent in the DVD packet, right? The same information in the DVD packet. This is the DVD packet I have sent. The router 1, the DVD packet. Hey, I have this information. I'm not sharing the info. I'm just saying that I have this information. What R2 is saying, hey, give it to me. This information. Who is sending? Router number 2 is sending. Now, what router 1 will do now? Router 1 will give the update packet now. If you see LS update, now he's sharing the detailed information. So if you see the detailed information now, from the short information, these are the short information we can call it, or summary information. Why call it summary information? Because this information doesn't have a more idea, right? More doesn't have a routes over there, doesn't have a more LSA information. Now I'm sending the LSA packet, LSU packet, where I have a multiple information. How the networks are connected, what's the flags of this guy, everything we have. That's called the detailed information. So this guy sent a DVD packet saying that I have these LSA. This guy's in the LSR packet. Link is shared, and then his guy is in the LSU packet. And now he will give the LSA acknowledgement. That's how your complete OSPF packets are working. All good? Don't worry about that, these things, right? Well, you will get to know that at the end of the day, you will get to know that each fields, right? Most of them will not each field, because many flags not a part of your syllabus, even not a part of the CCI enterprise. So most of the things are part of the CCI service part as well, some other part of the CCI enterprise as well. But many things, almost 70 to 60%, you will get to know that by end of the day. Right? So basically, these are the packet types we have in the OSPF protocol. Hello, DVD is going to contain the master and slave information, also contain the MTU information. Link state update packet, that's going to contain the LSA information. LSR means link state request packet. when I'm going to request for some information, LSA acknowledge just like a receipt of the LSU packet. All these packet, all these packet are encapsulated by IP header. Right? All these packets have what? All these packets has a own checksum field. These are not dependent on the IP header checksum. Checksum is just going to maintain your integrity. Right? So now these are all the packets we have done. So if you have a question, guys, feel free to ask me. Anyone has a doubts in the hello packet DVD packet? LSU, LSR, LS acknowledgement? Simple language, just remember the theory. So Bujar and Davol, and sorry, Bujar and Nidhi. So first, Bujar and Anil has formed the neighborship by sending the hello packet, and also with Nidhi as well. They send the hello packet and they form the neighborship in the childhood. After the 20 years, what happened? Bujar and Anil has met on the airport, and Bujar both are fighting. Hey, I have a huge information to share with you. They said I have a huge information to share with you. So we made a master and slave election, right? So the router ID who has the router who has a higher router ID will go with the master. The router with the lower router ID will go the slave, right? And then what happened? The master will first exchange the information by sending the DVD packet. Say, hey, I have a number of Nidhi, but I'm not saying the number of Nidhi, right? I'm just saying that I have a number of Nidhi. Then the Anil will say that, okay, give it to me. He's requesting, Anil is requesting now. Now the user will give the update packet. In the update packet, they put the Nidhi number. And now the Anil will give the acknowledgement. Thank you so much. That's how your packets are going to work. Right? So apart from this thing now, the most important concept that OSPF comes in the picture, that's called as a LSA. LSA stands for Link State Advertisement. Simple language, sharing the link information is known as a LSA. LSAs are stored in the database table, which is known as LSDB table, link state database table. Link state database table it's a collection of LSAs. Time for LSA. What is time for LSA? What do you mean by time for LSA? I'm not able to understand your question. Time for LSA. Maybe you are missing something, or maybe let me know or your question. Can you expand your question, right? Can you elaborate your question? So LSA is like, it's a link state advertisement. So LSDB, it's a collection of the LSAs we have. So we have a different types of LSA. So LSAs are depend, right, on the area's configuration. If you have a single area, right? If you have a single area, then you have only two LSA. If you have a single area, then you only have a two LSA information. The first LSA we call as a how long it take packet for exchange between two routers. It's depend on the network what we call performance and whatever the information you're exchanging over there. So the hello packet is a 10-second and like what we call the hold on time is a 40-second. So which packet you're talking about? You're talking the hello packet or like update packet? Update packet will be retransmitted at every 5 seconds. That's LSU packet retransmission will happen if there's no acknowledgement to see. And once I will generate the acknowledge packet, it's just a frequency. Depend on the delay of your network. There's no timer for that one. It's depend on the network time, delay of the network, how much delay we have in the network. So there's no specific time of the any acknowledgement packet. So if you have a single area, then you have a two, then you have only two LSA. The first LSA that is called as a router LSA, which is also known as a type 1 LSA. Right? Which is also known as a type 1 LSA. So sometimes people also call this guy the LSA number what? LSA 1. So basically what these guys do, right? So understand the concept, that's very, very important, right? So router LSA generated by each router. Generated by each router. It contains the information about how many links are attached in my, how many links are attached to my router. So you tell me one thing. First, focus on the name. Okay, we have a router LSA, which is known as the LSA type 1 LSA, also known as the LSA norm. It's generated by the each router. It's generated by each router in the sense of what? If you have a 10 router, then you have a 10 router LSA. If you have a 20 router, you have a 20 router LSA. If you have a 30 routers, you have a 30 router LSA. For example, 20 routers, 20 router LSA. If you have 10 routers, you have a 10 router LSA. Simple language. What this guy will contain? It contains the information about how many links are attached to my router, right? How many links are attached. So for example, understand the concept. So we have router number 1, we have router number 2, and we have router number 3. So we have a 0/0 interface, we have a 0/0 interface, we have a 0/1 interface, and we have a 0/0 interface. We have a link behind the router number 1, which is the wonder1. That's my loopback number 1. And we don't have any link behind the router number 2. We have a link behind the router number 3, which is the 3.3.3.3.3.3 loopback number 1 again. Understand the concept. In a OSPF protocol, as I told you that OSPF is a very smart protocol than EHRP. OSPF consider this loopback is a last route. There's no any network behind it. So they will consider this loopback as a stub network. They will consider this loopback as a stub network. Let me write down over there. So stub network as a loopback, right? And transit network, guys, please pay attention. Transit network, we have a fast Ethernet 0/, or any Ethernet. So in this diagram, we have a fast Ethernet. That's why I'm seeing the fast Ethernet over there right now. Understand over there. So these are called, you know what? These are called as a stub network right now. This is called as a what? This is the link we have 12.1, and this is the 12.2 we have. This is the 23.2 we have, and 23.3 we have. The network type we have over there, it's a, sorry, network will have a 10.1.12.0. The network we have it's 10.1.23.0. So this is called as what? This is called as a transit network. This is called as what? This is called as a transit network. Right? Guys, I need your help over here. Can anyone tell me how many router LSA in this network, in this topology? How many router LSA we have in this topology?
Four.
फोर कैसे दिख गया तुझे? How did you see the 4? How do you see the 2?
What's the question again?
What is the question? You missed that question. So question is, how many router LSA in this topology? Nishar said the 3, right? So 3 is the correct answer.
In this topology, 3 routers.
Simple, right? So I just mentioned that if you have 20 routers, 20 routers, 10 out of 20, 10 routers, simple. Focus on the definition, guys. If you don't understand the OSPF protocol, I'm telling you, you will never ever clear the any single interview. Telling you, really frankly, focus on the definition. It's very, very important. So of course, three routers, three router LSA. Now, what they will advertise in the router LSA. So when the router one, what I'll say that it contains the information about how many links are attached to my router. So basically router LSA is just gonna contain the link information. So when the router one, guys, pay attention. When the router one is gonna advertise the router LSA to the router number two. When the router one is gonna advertise the router LSA to the router number two. What he will tell this guy router number two? Hey, you know one thing, I have a two links. I have a two links. Which one? One link. That's a one. That's called as a stub network. And 12.1, which is called as a transit network. And of course, this will be the BDR, right? He will also mention that this will be the BDR over there. Why the BDR? Of course, the DR will be this guy, right? If you have a DR BDR, then if you don't have a DR BDR, you will not see the DR BDR over there. Then what router number two will tell this guy? Router two will say, hey, you know one thing? I have a two links connected to me, right? That's R2 is going to dash to the router number one. I have a two links connected to me, and both the link, the 12.2 and 23.2 is a transit network. Same thing, router 2 also going to advertise the same information router LSA to this guy, right? How many links? So is it the 12.1 and 23.2 as a transit network. Same thing, R3 is also going to advertise the router LSA to this guy, router 2, and say, hey, I have a two links connected to me. One link is the 3.3.3.3.3.3, which is the stop network. And one is the 23.3, which is the transit link. Why I say the call as a transit link? Because through this particular link, I can send my data traffic. Through this particular link, I can send my data traffic. That's why we call it a transit link, transit network. I hope everyone has understood this part, the meaning of this two line, transit and stop concept, stop network concept. Stop network is a different thing. Stop area is a different thing. And OSPF stub is a different thing. In a OSPF routing protocol, this stub terminology you may encounter 3 to 4 times. Okay, EIGRP stub is a different thing. So router LSA is just gonna contain the link information, how many links are attached to me. So if you see right now, let me show you this topology, not this one. And I can show you this one as well, right? That's okay. Let me go with this one because it will give you the very less information. This one, I have a big topology. Let me start my devices. And meantime, just be back 1 minute. Let me have my water. Okay, so let me back this guy. Come on. Have a look right now. So let me see what are the IPs there or not, first of all. I have a IP, perfect, router 3. I have IP on router 2 as well, router 3. Have IP on router 3 as well, R4. I have R4 IP as well, R5. Perfect, and R6 as well. So now what I can do that, I'll simply gonna configure the OSPF on this router. So simple configuration, I just need to go in the router as the config terminal, as the interface 0/0. So you have another way to configure the OSPF, like at interface label. So I'm gonna configure the OSPF protocol. OSPF works on the IP protocol. That's why I first give the IP keyword. Then answer which protocol I'm gonna enable. As the OSPF protocol I'm gonna enable. Which process ID you have. I'm planning to run the process ID 1 over there. Okay, this interface to be part of the which area? The area should be 0. Simple one. So let's go on the router number 1. Okay, there's one problem. So I have configured the OSPF on all the 6 router. So wait for the 40 second if you see that. So IP show IP or show IP OSPF interface. If you see that there's no DR and media, wait time before the DR media election. So we have to wait for the 6 more second more. So we don't have any DR and media now because the wait is going on. So once the election will be done, so they will find who will be the DR and VDR. And now I can see that. So router 1 is forming the neighbor the 6.6.6.6. Okay, that's my DR, but who is the VDR? VDR is a 555. Perfect, right? So of course my router 6 will be the DR router, and router 5 will be the VDR router. And the remaining all the DRO and DRO, right? So DRO only have a neighborship, and DR to BDR, DRO to BDR, and DRO to DR, you have a neighborship adjacency as well. So on the router number 1, you will have almost all 6 neighborship, but only the 2 adjacency. You will have a 6 neighborship, but the 2 adjacency. So neighbor, not a 6, of course 5. My bad. I counted myself. So on the router number 1, you will have a 5 neighbor and 2 adjacent. The 2 adjacents only will happen with the backup DR and DR, right? But R2, if you not R2, R6, if you see R6 is my DR, I will have a 5 neighbor and 5 what? Adjacent as well. That's a difference. Now, guys, help me out. How many router LS will be there in this picture? And this red one right now, only this diagram. Till this point, how many router LS will be there?
6.
Sorry?
6. 6, sir.
6 router LS will be there, right? So if you check on any router right now, let's have a look at the database table. Show IP OSPF database right now. This is the command to check the LSDB table. You will see that that's OSPF process ID, router ID will be 1.1.1. That's on the router number 1. I'm looking right now. That's why I say the router ID 1.1. Process ID 1, and this is for the area 0 right now. Router LSA. The first thing in the router LSA, we have a link ID. Link ID is just nothing but it's just a router ID of the router. Link ID is just nothing but just a router ID of the router. Advertising router means what? Who is advertising this LSA? Same one. So link ID will be changed if you see that in the network LSA. We'll see that network LSA in the next like after the 5 to 10 minutes. So if you see the network LSA, link ID will be changed. So link ID will be changed depend on the LSA type. So in the router LSA, the link ID is the router ID of the router. Let me write on this thing. Now I'll go in the different location. I'll better to put this guy in this way. Hold on. So that's the command to check the database table, OSPF database. So this is the OSPF router ID 1.1.1. That's I'm looking for the router number 1. Host ID 1.1.1, 60 meter mark. This is area 0, right? So this link ID that you can see the first thing over there. That's in the router LSA, the link ID will be router ID of the router. Okay. Advertising data, of course, it's gonna tell you the who is advertising this LSA. Of course, router 1 is advertising this LSA. That's why you are seeing that advertising this LSA. That's why you see that 1.1.1 over there. Age is just a timer of the LSA. Timer of the LSA. So the max timer, it will go with the 60 minute. That's called as a 1 hour as well, right? That's it is known as a what we call max LSA time, right? And within a half of this, so not half of 30 minutes is called as a, we can call it the 1800 second as well. It's called LSA refresh time. So LSA will be refreshed at every 30 minutes. So somehow, maybe if your LSA will be not refreshed in the 30 minutes, then what happened after the 60 minutes, this information will be flushed out from the database table, right? If the somehow the LSA will be not refreshed, right? Then after that, you have a sequence number. It is a 32-bit number, right? So always start with the 0x8000 0001. So the starting is a 0, but 0 is the reserve. So that's why you will see the 1. And whenever the any changes is happening in this database table, then what happened? Your sequence number will be upgraded by 1 over there. So it's a 32-bit number. It is just gonna, the starting point is 0 over there, and then 1, 2, 3, 4, 5, so on. And the checksum is just gonna maintain the integrity that we already checked. And the link count is just gonna tell you how many links are attached to this particular router. So of course, 1 link, right? Because I just enable, if you see on the router number 1, how many links are enabled on this source web. So IPOS interface brief. So only 1 link, right? This is the link is enabled in the OSPF protocol. That's why it's saying that 1 link only. Right? If you have a look, right? If you go on the router number 1, if you see the detailed information, now understand the concept. You are sitting on the router number 1, and you can check the detailed information of any router. How? If you put the command show IP OSPF, right? Database, router. If you put the keyword router over there, it will show you the detailed information about the router LSA. LSA is, it will be keep incrementing by 1 second. Okay, it will be keep incrementing the by 1 second. Once it will reaches to the 1800 second, it will be refreshed, and again back to the 0. And again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 100, 100, 200, 300 will go. So option is a no toss capability we have. So that's, we don't have toss capability right now enabled. So in the older time, we were using the toss capability. Now we are using the DSCP over there. That's why it's in the no toss. DC is just going to say the demand circuit we don't have right now. LSA type is the router links. A link state ID is a 1.1.1. That's a router. 1.1 is a router 1. And who is advertising this LSA? The LSA is advertised by the router 1, which is the router ID 1. LSA sequence number, we have seen that checksum, we have seen the listen. Number of links of the router number 1, we have a one link, which is called the transit network. And what is the IP address for this guy? 1.1.1. Same thing now, if you look for the R2. You are sitting on the router number 1, I'm checking the router number 2 database. Can you see that? So I'm sitting on the router number 1 and I can see that what is the IP address of the router number 2. See, I can see that router number 2 is advertising the one link, which is the transit. How about the router 3 now? Router 3 is also advertising the one link, which is now 1.3 now. But all they have a same DR. All they have a same DR. So he's also saying that, hey, my DR is a 106. He's also saying my DR is 106. He's also saying my DR is 106. Now I'm sitting on the router 1. I can see the information of router 4 as well. One link, which is the transit. And for this guy, he's also DR. Now I can see the R5. R5 is also advertising the one link right now. Same DR. Okay, I'll put the 1.6 as well over there. I'm sitting on the router number 1. You can see that I'm sitting on the router number 1. I'm seeing all the information. Now it's R6 now. R6, we have one link, transit network, and 1.6 is the DR. And same router interface is the 1.6 and same DR IP address as well. Over there, if you see, it's a difference. Same. So I can find now he's a DR router, and every router has the same DR. It means that all they are part of the same broadcast domain right now. So they have advertised only one link. That's why you see the one transit network. Let's do one thing. If you see one thing, show IP OSPF database right now, what you can see that the sequence number is 2, age is 560, checksum is B895, link count is what? If I'm going to add the another link right now, interface loopback number 1, I'm just going to enable. If you see, I have an interface brief, I have a loopback number 1. I'm just going to enable the IP OSPF 180 for this particular. I'm just advertising this particular link. So I can advertise by the interface label command, or either you can use the network statement. Both are fine. If I put the enter over there, what happened? This age will be reset. The sequence number will be increased by 1, and checksum will be modified, and link count will be increased. Have a look. Only in this particular database, only in this particular LSA, not in the different one, because I advertise the router on this router only, not the other router. Can you see that? Change, start with 0. It happened in the 22 seconds, that's why I'm saying 22 right now. 3, checksum has changed and link count has changed. Previously it was 1, 895, 888, yeah. So now if you put the command, now if you're sitting on the router number 4, now you are on the router number 4, and I can see the information, hey, now on the router, guys, attention over there, I am on the router number 4. And on the router number 4, I just want to see that how many links that R1 has. Router, let's say. If you see, he has the 2 links. He has 2 links. One link is a stub network. If you see, it's a /8 network. How OSPF is advertising it? 32. That's a beauty part of the OSPF protocol. Save the memory and save the CPU. Save the lots of IP addresses. And another link we have, one link is the stub, another link we have is called the transit network, which is the 101. All good? That's all about the router LSA. Let me do one thing. Let me configure this guy as well, and I'll show you the more information. Now on R5, I'm going to configure this interface. So let me check. Let me enable this interface 1/0, IP OSPF number 180 on a router number 6 as well, not router 6, router 7. interface 1/0, IP OSPF number 1, area 0, and interface 0/0, IP area 0. Same thing on the router 7. I also need to configure the interface 0/0. Now, in that case, what happened? All they belong to the same area, right? Right now, all this router in the same area. So now, how many LSA you will have? 1, 2, 3, 4, 5, 6, 7, 8. You will have a 8 router LSA. Now see the beauty part. It's not possible in the case of EIGRP. In a EIGRP works on the routing by numbers. So in a EIGRP, what happened? You only have a detailed information about the neighbor. R5 only has a detailed information about the R7. R5 could not have a detailed information on R8. But in the OSPF protocol, if you have a look now, let me see the neighborship came up or not. It came. R7 come up and R6, R5, it came. Now you just go on the router number 1. Have a look. Previously, we had a 6 LSAs router. Now you will have a 8. Eight router LSA we have. These are the 2 new ones. If you see, I'm sitting on the router number 1. I do have ability. I can see the detailed information about the router 7. What is the IP address and how many links are connected to this guy? Can you see that? 2 links. I want to see that what is the IP address of this guy. So do show IP host for database. Router. Sorry, command is wrong. Show IP OSPF database router. And I'm sitting on the router number 1. Have a look. Just go down. Go with the 7077. It's 5. It's 6. It's 7. You can see on a 7, I'm sitting on the router number 1. I can see that what information are present on the router 7. 2 links are there. Whatever the links they have. One is called the transit network that has IP address 78.7. The DR for this guy is 78.8. Another link I have is called the 57.7 and DR is also 57.7. This thing I can see in those, so which is not possible in the case of EIGRP. Even I want to see the router 8, I can see that. Router 8 has this information. That's why OSPF is also called as a, it contained, right? It behaved like a map of the topology. It created the map. It created the map of the topology, right? It's like a Google map we have for the cities to find the shortest path. There will be no loop, right? Same thing. OSPF is an amazing protocol, the brilliant protocol that creates the map of the topology. And based on the map, he will figure out, okay, which one is the shortest path for me? And it creates the loop-free topology because of the area 0 concept. So in an EIGRP, we have a mechanism to prevent the loop, like a router ID concept, we have to prevent the loop. Split horizon loop behavior, we have to prevent the loop, right? But in an OSPF protocol, we have it's a loop-free protocol. Yeah, when you go with the higher level, like a service provider level, you will see the something called as a down bit, DN bit. So DN bit is a one way that you can prevent the loop when you go in the advanced level. But that's I'm not discussing right now, leave it right now. But yeah, at this level of the even the enterprise level, CCI level, yeah, OSPF is a loop-free protocol. Area 0 is helping me to prevent the loop. Because in a complete area, sorry, in a complete network, you will only have one area. You will not, sorry, you will only have a one area 0. You cannot create the multiple area 0. So this beauty I can only have in my OSPF protocol, not in the other protocol. And because of this reason, can you see that I'm sitting on the router number 1? I can see what information are present on the router number 8. It's a different broadcast domain. Because of that reason, it is always recommendation to configure the OSPF protocol. I'm so sorry. To configure the OSPF protocol inside the service provider network. It is always recommendation go with the OSPF protocol or ISS protocol because both are a link state routing protocol. And the behavior of the link state routing protocol is what? Within the area, each router has a identical information. So if you check on the router number 1 or router number 3 or router number 5 even, you will have a same database table on every router. Same database table on every router. Sequence number will be same, checksum will be same. If you see right now, on the router number 1, I have a what we call. If you see this guy on next, let me show. So IP OSPF database. So if you see one thing, right on the router number 1, what you can figure out, for the router 5, we have a sequence number is 4 on the router number 1 right now. Sequence number is 4, and the checksum is EE7, the last one. The same information you can check on the router 8, it will be same. So within the area, you will have a same information. Can you see that? Same one on the router 8 as well. The 4 sequence number, EE7. So either you're sitting on the router 1 or either sitting on the router 8, you will have an identical database on each router. And because of that reason, it creates the map of the topology. And always go with those protocol in the service provider network. Always recommendation. Because it helps you to, deploy the traffic engineering and a segment routing. Again, advanced level things, but just to let you know that because of that reason, because of this two behavior, right? I need to go with those protocol or ISS protocol in the service protocol. So major task is what I'm trying to say that OSPF router LSA is only going to contain the link information. So router 1, router 2 we have. So doesn't matter how many links they have, doesn't matter how many links they have. Router 1 is only going to generate the one single router LSA. And in that single router LSA, he will put all the link information 1, 2, 3, 4, 5, 6, 7. He will put the 7 link I have. So 6 link will be stuff. I can consider it because of the loopback. 1 link is my transit network. So total 7 link is going to do. So if they don't have any loopback, he will say that, hey, I have a router LSA, but I will only advertise the 1 link, which is my transit link 0/0. Guys, anyone has a questions in the router LSA?
So, in regards to the sequence number, if the two routers are they are not sharing the same database, like for example, the router number 5, right?
You have
So,
same number. As the identical information, same will be there everywhere.
no, let's say about the router number 1, 2, 6.
Your voice is breaking. Your voice is breaking, Ali. Hello, your voice is breaking.
Sorry?
Your voice is breaking.
Just hold on. So, router number 1, can you hear me now?
Yeah, go ahead.
Hello?
Yeah, go ahead.
Can you hear me now?
Yeah, I can hear you. I can hear you. Go ahead.
Hello?
I can hear you, Nasir. I can hear you. Go ahead.
Hello?
Hey, look like you have an issue with the voice. Not
Can you
clear.
hear me?
Yeah, I can hear you. I think he has some issue. Okay, anyways, anyone has a question, guys, about the router LSC? Yes, we can hear you. So next type of LSA we have, let me cover this part. So next type of LSA we have is called as a network LSA, right? That's called as type 2 LSA. And sometimes it's called as LSA number 2. Focus on the name generated by DR only. It contains the how many routers are attached in my broadcast domain. So of course, it's generated by the DR only. It means that what? For each broadcast domain, why the router one has two links? Because I have advertised the two links over there. On a router one, I have advertised the loopback and transit link. That's why. If you see show IP, show, right system. So IP OSPF interface brief. Our two links over. I advertised both the link. I can't hear you. You have an issue with the internet, Nashik.
I can hear you now.
Yeah, tell me.
Sorry, excuse me. My question was in regards to sequence numbers.
Okay.
So I understand if the two routers are neighbor to each other,
Mhm.
for example, router 5 is working as a transit router between the 7 and others, right?
Mhm.
So that means sharing the database to each other.
Yeah, sharing
So
the information. So eventually they are all part in the same area, right?
yeah, eventually they are the part of the same area. That's true.
So within the
And
same area, they have identical information.
yes, they are part of the area 0, right?
Yeah.
1 to 8.
Right.
So I was talking about the sequence numbers.
Yeah, tell me.
How every router has its own sequence number,
Every
or
LC has its own sequence number, not the data.
so
Every LC.
what about these links? Links means what?
Link count, how many links you have enabled in the OSPF protocol. So on the router number 1, I have enabled the 2 links, right? Loopback 1 and 0/0. That's why you see the 2 over there. But on the router number
Okay.
1, I just enabled the 1 link. That's why you see the 1 over there.
On router number 1 you have enabled
2 links.
on. Okay, and router number 2 you don't have loopback, right?
I know, I just have enabled the 1 link over there. That's all.
There is the loopback, right?
Just I have enabled the first 0/0.
Okay, so but if you configure the loopback, it will
So then it will come to the 2 over there. So if I'm going to configure the loopback over there, for example, IP OSPF 1 and area 0. So what happened on the router number 1? This will be reset by 0 now. This will be sequence number will be increased by 1. Checksum will be changed and the link count will be increased over there. Have a look. Interface and now go to the router 1. You can see it has changed now. Sequence change, checksum change, and link count has increased.
if you enable it, right? If you do
I
not
just
enable,
advertise it. Yeah, that's all.
oh yes, you have to advertise basically, right?
Yeah, enable
That's
means
what you mean.
advertise it, right?
Okay, because the loopback you don't have, they will come up automatically. You don't have to unshut.
Oh
Isn't
yeah,
it?
for by default the loopback is up. We just need to
Absolutely.
IP address and thus enable the interface.
Okay, so when it means enable, that means you are advertising the network, right?
Exactly.
Okay.
Enable means advertising them. So either you can enable by the network statement, either you can enable by the interface level.
So if you talk about the network statement, means what? We are advertising the networks, right? of that
Yeah,
particular.
eventually we are enabling the interface in the network statement as well. Remember the theory of the network statement, what I told you, that it enabled the interface into the particular routing protocol. It joined the multicast group. Same command, it enabled the interface into the particular routing protocol. Nasir, you understood or not?
So
Yeah, go ahead.
so if you say you have an advertise the network statement, right?
Not advertise the network statement. What is the use of network statement, guys? Anyone can explain me? What is the use of
Yeah,
network?
sorry, I was a bit, I mixed up the question.
Yeah.
So the the
Network
network
statement is used to enable the interface, right? Into the particular routing protocol. What is the use of this command again? Interface label, IP OSPF 1 area 0. The same thing. Used to enable the interface into the routing protocol. So we have a 2 ways to advertise the route in the OSPF. One way is a global mode. That's you can use the network statement. One is the interface mode, which is not happening in the EHRP, which is happening in the OSPF protocol. Is there any advantage by using a no, there's no advantage. So yeah, like if I talk about the CCI lab perspective, so yeah, they will dictate you have to use the network statement or the OSPF interface. So for example, if they dictate you have to configure the interface label, and by mistakenly you have configured the global label, then you will fail in the exam. Otherwise, no, there's no other one. You understood, Nasi, now?
yes, I got clear now. So it's used to enable the interface into the routing protocol. So enable the interface means that means it's advertising the loopback, is also advertising the whatever the IP address we have configured.
Exactly. Whatever the IP address that will be part of the loopback will be advertised in the OSPF protocol.
Basically, one is loopback interface and the other one is just the like a normal interface. The both
Yeah.
are
Both are advertised in the OSPF protocol.
and that is called the network statement.
You can call it. You can call it. So normally network statement is how you just need to go on the router side, router OSPF number 1 and say the network 10.1.12.0 like this way, right? Area 0. So same way I configure it. So either you can do like this way or you can do like this way. It's up to you. You understood?
Hello?
Hello?
Right.
Where are you missing? Just tell me, I'll help you that. Where are you missing? Did you miss something or anything like?
Can you hear me?
Yeah, I can hear you, Nasir. Can you hear me? Hello? 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 Hey, Nasir, it looks
Yeah,
like
sure.
you have a,
I had yeah. But it's okay.
You understood the difference now?
Yes. Used to enable them. Yeah, that's fine. So two ways
Two ways to
advertise the
advertise the route in the OSPF protocol. One, you can advertise the route in the global ways, and second, you can advertise by the interface ways. So this is the global ways that we have, and this interface label we have.
So the global ways is
In a global ways, you need to put the wildcard mask. In this way, you don't need to put the wildcard mask.
okay, that's fine.
So this is the IP. Of course, in this interface, we have IP address, right? 10.1.12.1/24, right? So we are advertising the route anyways, right?
This is the global way, right?
This is the interface way.
Sorry, this is the interface way,
This
right?
is the global way. Now you got that?
So basically, in global way, you do advertise the wildcast mask, and the interface you just put the subnet mask this way. That's
Where I'm
it.
putting the summary, I'm not putting the summary. Can you put the, did you see the summary mask over there in the OSPF command? This is the IP address that I've configured.
No, this is okay, but this is IP address, right? But that's
Yeah, this
fine.
IP address. I have advertised the AI just OSPF. Did I put the submit mask over there in the OSPF line? No.
IP OSPF. But here you put the IP address 10.1.12.1, then subnet mask,
Mhm.
then IP OSPF 1AO.
Area 0.
Okay, so either you put the wildcard mask, or you just put the IPS OSPF 1 area 0. That's it.
Anything is fine.
Either way.
Anything is fine.
IP OSPF 1 is the router ID, right?
OSPF 1 is a process ID.
Sorry, the process ID. Sorry, yeah, process ID. Okay. No problem. That's fine. Got it now.
Right.
Okay. Good. That's absolutely fine. Thank you so much.
Most of it. So another type of LSA we have is called as a network LSA, guys. Pay attention. Network LSA is called as a type 2 LSA. LSA number 2 generated by the DR only. Most important line. DR only. So in a one broadcast domain, you have a one DR. Right? So if you have a 2 DR in your broadcast domain, then you have a 2 network LSA. And this guy is going to contain how many routers are attached in my domain. So it contains the how many interface are attached, how many links are attached in my router. It's going to contain the how many routers are attached in my domain. So tell me one thing. In this broadcast domain, who will be the DR? This guy? Who will be the DR in this broadcast domain? This guy? And who will be the DR? Let me check who is the DR in this broadcast domain first. I just need to go in the router 5 and Nego. So 707 is DR, that's fine. So he's a DR also. And this will be also DR. So of course, in this complete area 0, if you can see that, I have a 3 DR. So how many network LSA you will have? You will have a 3 network LSA because we have a 3 broadcast domain we have right now. 3 network LSA, right? So you can check on the any of the router, doesn't matter. Any of the router if you stick on the router 1. So IP OSPF database, you can see that we have a 3 network LSA. One network LSA is generated by the 1.1.6, which is the router 6, right? Another network LSA is generated by the 57.7, which is the router 7. And another network LSA is generated by the router 8, 78.8. Same information, age mean is same, sequence number is same, checksum is same. So if you see how many routers are attached, so IP OSPF database, now you can put the network keyword. What you will see that, right? Understand the concept, guys. In the link ID, we have a router ID. In the router LSA, the link ID of the network LSA is going to have a DR IP address. This is important line. 1 minute. Let me explain you this thing because it's really important for the interview perspective. Okay, let me remove this guy from here. I don't need it. And I'll put this guy over here. So the top one, you can see that's a router LSA. This is the network LSA we have, right? And the link ID over here is going to represent that DR IP address. The link ID over here is representing the router ID of the router LSA. Advertising router is the router ID of the router. And remaining the 8 sequence number checksum is the same like a router LSA. So if you check on the router number 1, so IP OSPF database network, what you can see that figure out in my domain right now, how many routers are present in the 1.0.6 router. So what link state 1.6 is saying that's a router, let's say, generated by the DR. Advertising router 6.6.6.6. R6 is saying that, hey, in my domain right now, I have a 6 router attached. Same way, this is the another router, let's say we have over there. Sorry, another network, let's say we have on the router 7. Router 7 will say that, hey, I have a 2 routers attached in my network. Right? Another network, let's say, generated by the R8. R8 will say that, hey, I have another 2 routers attached in my network. So can you see that how the OSPF works? OSPF will give you the link information, the IP addresses information, and also give you how many routers are attached in my domain. A detailed information you have within the area. That's why it's called as a, right, within the area. Where is that? That's why it's called as a within the area. That's why it's called as a within the area. It has a detailed information. OSPF maintains the detailed information. But between the area, summary information. So within the area, it behave like a, not behave like a, it, within the area, it works, not works. Within the area, we can call it, how I can define this guy. Within the area, we call link state routing protocol. Between the area, we call distance vector routing protocol. Because between the area, we are not sharing the detailed information. Detailed information are only present within the area, but between the areas, we are going to only share the summary information, the short information. And that's why within the area, it's called as a link state routing protocol. And between the area, we call as a distance vector routing protocol. So I'm done for the today, guys. So if you have any questions, you guys feel free to ask me anything in the router and network LSA. These two LSA, always remember, it's only present within the area. It will never go beyond the area. Never ever. Two types of link will have over there. Either you can have a stub and transit. The stub will be loop back and transit will go faster than it. Anyone has questions?
Sorry, if you have a single area, then you have only two LSs. The one,
Router one is the network, that's all. Single means one area 0.
okay. Then you have two LSs,
One area.
LSA type 1 and LSA type 2.
Right, exactly.
Okay, and that is a single
Single
for
area.
it can be area 0, area 1, or area 2,
Anything,
whatever.
either area 0, either area 1, area 2, anything. Single area, two areas only.
And if there are multi areas,
I'll come to the point, don't worry. Tomorrow we'll see that.
no problem. Understand. No worries. Thank you so much. No worries.
Anyone else?
Yes,
Any
cool.
question, guys? I'll save this paint file.
I mean, if you can share this file into your documents, that would be helpful.
Sure, buddy. Let me see.
No problem.
Where's my, okay, OSPF. I already have it. That's the one. Thanks. Okay, guys. So we'll catch you tomorrow with the multi-area concept. So OSPF is a way, two ways to deploy the OSPF. One is a single area, another is called the multi-area concept. So multi-area, you will see that tomorrow. Okay. So
Okay.
we'll do the
All
lot
right.
of things like LSA3, LSA4, LSA5 as well. Right. So interesting things comes tomorrow. But please watch the today videos. Very, very important, because if you don't understand the today videos, tomorrow will become very hard for everyone. Okay. Please watch it.
Okay, sir. Okay, sir.
Okay, guys, have a good night, everybody. See you tomorrow. Bye-bye.
Yeah, so we'll be waiting for the video.
I'm gonna upload the video right now in the next 20 minutes.
Okay. All right.
Sure.
Thank you.
Bye-bye.
Thank you. Bye-bye.
Thank you, guys.
Good night, sir.
Good night, good night, good night.